Hello, everyone. Today we're going to be talking about what are Python data types. Data types are an essential concept for any new programmer to understand. But first, let's address the question, why do we need data types? Data types help us categorize and organize different kinds of information in our programs. They allow us to specify what kind of data a variable can hold and determine how that data can be manipulated. Understanding data types is fundamental to writing effective and efficient code. Just to clarify, when I reference the term data types, I'm talking about anything that's being utilized in your program. For example, a sentence that maybe a person is going to say to greet somebody else, that would be known as a string, which is a Python data type. If we're making some sort of calculator application or algorithm, we would be manipulating numbers or integers, which is another Python data type. So we'll be taking a look at all of these different data types, how they work, and what their powers are here in this next couple of lectures. Let's start with integers. Integers are whole numbers, both positive and negative, with no decimal point. They can be used for counting and performing mathematical operations. Floats are numbers with a decimal point, allowing for fractional values. They're useful for representing quantities that are not whole numbers. Strings are sequences of characters enclosed in either single or double quotes. They are used to represent text data in Python. The key thing here is single or double quotes. You'll notice the example on the slide deck here shows double quotes, but that is not a necessity. It could have single quotes. I do strongly recommend utilizing double quotes whenever writing in a string inside of Python. We'll be covering the reason why later on, but just want to leave that Easter egg here for future reference. Booleans represent truth values, such as true or false. They're often using conditional statements and logical operations. The none type represents the absence of a value. It's commonly used to signify a missing or undefined value. Notice that there's nothing on the slide, right? None means nothing. It's non-existent. Then we have lists. Lists are essentially just like a train with cards. Each cart inside of this train can hold a different item, and you can add or remove carts or items into each individual cart as needed. List allows to store and manipulate collections of data. Next, we have tuples. Tuples, although similar to list, are immutable, meaning you cannot change them. The first time I heard of the word mutable or immutable, my immediate thought was to think about TV, whether it's muting or unmuting a TV. Well, that's not at all what the word mutable stands for. Instead, mutable is referencing to something, not to sound too geeky here, but for example, mutants, right? It's something that can be mutated versus something that cannot be mutated. Immutable means not able to mutate, and mutable is something that can be mutated, meaning I can change it. Tuples cannot be changed once established in memory. Then we have sets. Sets are collections of unique elements. Think of them as a storage of snowflakes. Each snowflake is unique, and duplicates are automatically removed. So it doesn't work like a list. It doesn't necessarily work like a tuple. It's still a collection of data, but it is very picky about what data it is allowed to hold. It will not hold more than one instance of an item. That's why we think about snowflakes, right? Every single snowflake is unique. So is every single item within this collection of data. And then finally, we have dictionaries. Oh, excuse me. Next, we have dictionaries, which dictionaries are kind of like a drawer where every single item is stored inside of one of these drawers, right? But they all are locked away. And the only way to access each one of these items is with the correct key. So here we see the picture. We have this massive drawer and we have the set of keys. Well, in order to grab any information out of this dictionary, we would need to call or grab the corresponding key for the item that we want to grab. Now, something to consider when it comes to dictionaries is that dictionaries also enable us to have direct access to all of our data. While in the previous data structures that we've talked about, you may have to do some sort of iteration or other forms of manipulation to be able to find the value that you're looking for. But a dictionary, you set a specific drawer for this value and you have a specific key. So when you call this specific key or you grab this specific key and go to open up the drawer, there's no iteration, there's no looking or shuffling through different values. You're going straight to the corresponding area, grabbing your key and grabbing the information that you need. And finally, we have functions. So functions are blocks of reusable code that perform a specific task. They may or may not take input and may or may not provide some output, but the concept to understand is that the body of the function is a reusable set of instructions. I'm sure we've seen this before, whether it's in math or other sort of pictures. You'll see that in this picture demonstrated above, the function itself is the machine, right? We have our function machine. We have inputs, which may or may not be provided or necessary. And we have outputs, which again may or may not be provided or necessary. Now, when we talk about variables, variables are just a useful way to store these data types in memory within our script. Think of them as boxes that we can label so we can store information inside of these boxes. The way Python works is we talked about how it's a runtime program, meaning it runs from the very top of our script or program to the very bottom. But it doesn't necessarily retain information or memorize information unless you tell it to. This is where a variable comes in. We have our boxes. We have a box that we tell Python, hey, inside of this box, I'm going to hold this number. And I want you to take care of this box and hold it in memory. And when I need the value of what's inside of this box, I will reference it by the label on the box. We'll talk about variables later on. All these concepts are a little bit confusing when we're talking about in a superficial standpoint, but once we start working and actually doing some practical application, this will make a lot more sense. Understanding Python data types is crucial for writing effective and efficient code. By mastering these fundamental concepts, you'll be well equipped to tackle a wide range of programming tasks. Thank you so much. And please, we're going to be diving into each one of these data types in a lot more depth here in the upcoming lectures. So before you go out there and try to research all the extra information about all of them, make sure you take the time to go through the remaining of the course, get the information that we're providing, and then do your additional research. Thank you so much, everyone, and I hope to see you again soon.